Think of your system like a car dashboard. If you don't see speed, fuel warning, you're still moving, but you are moving blind. That's what mutation look like without an observability. It doesn't improve, it just keeps changing. You need a surface that tells you which difference matters, which pattern keeps failing, and when humans should step in. This lesson built that surface. This is the difference between engineering and the guesswork. Think this whole course as a one system or a one big example. Each lesson adds something new, but the earlier ones are still running underneath. So if you need to brush up those earlier concepts, just click the YouTube card on the top right corner to jump back to the playlist. In earlier lesson, we separated reader, proposal and crucible inside the orchestrator. The autogen, the framework we use, seems useful only if we can inspect the artifact it produces. We are not starting here over, we are just adding the observability to receive better feedback signals. So keep the full system in mind. Let's understand the memory of the loop using this simple architecture diagram. What it combines? It combines the run history, strategy, state, live evidences and operator control. Run history should always answer these three questions. Is the loop improving? Is it repeating the same message? Or is it plateauing? If it cannot explain the current run, then likely it has no value. There is a core of observability. You must see what difference, what changes, which metrics moved, and what decision followed. That's a linkage and that's a real feedback signal. Even the autonomous loop may tap control. You should be able to continue reset and intervene. Repeated failures often signals missing knowledge, not just missing effort. Observability, in my view, is not just a dashboard. It is a combination of history, evidence, and control. Read the artifact like an operator. Don't ask, delete parts once. No. Just ask, what happened across the last 3 runs? What patterns do you see? And what do you do next? This is the skill that this particular lesson built. So let's go on hands-on level and understand there. We are on our Visual Studio Code. If you haven't checked out our example, then please find the GitHub link in description below. You can start with observability feedback, or like every other lesson, we got this markdown file where to start. It has some catch up on earlier part. You can also catch up on the first 3 lessons you want. But these are the 4 important points which I want to discuss. First, observability. Treat always like an external memory. It's one of the most valuable data that you will capture. It will help you to make your autonomous decisions better and better every time. Most importantly, those mutation and small decisions, so you can let the mutation surface grow and your pipeline become broader and broader. Therefore, it will be able to handle far more edge cases than we have started it, than the starting point. And that's the real use case of this observability as an external memory. Always remember the score and traces are 2 different questions and they should answer 2 different questions as well. The score answer, did it improve? It's just a matrices. It can tell you holistic view. But the traces will actually tell you what happened to this particular use case, what happened to this particular row, or what happened to this particular application that comes. For example, why it is important. Score traces and the row level traces. If let's say I'm applying for a loan, you have an autonomous agent such as like this, which process that decision. Multiple agents spread across the distributed architecture. Well, when it onboards, how will he establish that each and every system do know a process scope? It's a business process scope. It's not a system process, so it cannot retrieve. So the very first onboarding system can generate some sort of a correlation ID, which we walk through across all the system. And whenever we want to retrieve those information or observabilities, observable points, we can actually retrieve using the same correlation ID. The reason, because application can be processed twice or thrice. We want to see each and every atomic process and how it works. And that's why this is important. Missing artifact is also very important feedback that one should not miss out. Well, I have added some code anchors. I would strongly recommend you to visit them. We are using all of our observability platform in this example that use the OpenTel, but we are not using the OpenTel backends such as like Grafana, Prometheus, or anywhere else, because we don't want to add extra burden on the users or learners. So we are just using simple JSON for persistency. However, in production use cases, someone might use the OpenTel collectors, or they might be using Grafana stack, Datadog stack, any of similar proprietary or open source architecture and stack. The reason is because it will provide better control for production system. However, for example, this is sufficiently enough. It can store the same architecture, same design, and same attributes in JSON 5, and we'll walk that in the dashboard itself. So it stores everything here by per run, and we can actually understand what is happening there as well. So let's go back on our code. Yes, so you can always walk through everything that that is essential for this trace recorder. You can see and try to observe that how we are actually building the trace runs, run IDs, and the correlation ID. That's actually the understanding that we need to build across this whole example. Correlations IDs are absolutely essential and one of the keystone and key skill when we build any observability platform. So let's go back on our documentation. You can actually run using the dashboard where I'm already running it, and I got my dashboard open. In this dashboard, I have done very simple thing. Is like you can see the run, how many runs we have processed. The first page operator signals give you the overall health of this particular dashboard and application. The score timeline will give you the historical comparisons. The round blueprint will basically give you the mutation surface, how many mutation surface we got and what we made changes to. For example, here the deterministic mutation has been added, then it managed to add the mutation playbook, which is basically the response from LLM. The deterministic when basically processed according to the rules that we have already defined. But beyond that point, if they do not success on those criteria of deterministic, then the mutation will be applied here. Why this is important? Because every time the code has changed, one of the core essential factor that you want to check from not just observability but also the compliance point of view is what was your mutated code look like? Was it dangerous? Was it stable, or was it accurate? Was it biased? All those aspects are absolutely essential to understand, and more importantly, what edge cases it left. What kind of how can I improve this mutation better by providing more information and more context to LLMs. So when the runtime the mutation happen, we can cover more and more edge cases. So these are the areas, these are the answer that all dashboard tabs will provide. Each dashboard tab will provide individual answer. For example, here it will provide that what happened to this particular invoice that we are talking about. Let me go and find 209, and you can see it has identified as a category escalated coming from decision was deterministic row, and it was processed pretty much. And what it input and sidecar rows look like, it pretty much gives us the clear understanding of what happened. Now let's see 214, which is basically a mutation playbook. So we can see it wasn't able to process the unmapped token amount. That was the reason why we need to run the mutation, and it does exactly what we did with it. And then it also tells the input and the sidecar rows, which is pretty awesome because it comes from two different places, flags and failures, and then how we manage itself. We can also see the trace timeline here. So let's see 214 clean data, hotel records, and its trace IDs is a correlation ID, and what was the recall delta. The same thing from an observability point of view, the broader observability, what actually happened, the overall trace spans across the runs and execution logs and diagnostics. Well, it's a quite detailed dashboard to walk through, and I don't want to spend 30 minutes walking through the dashboard, but it's very easy. You can run this dashboard, but I would like you to offline walk through this in detail and as much as possible. Now let's go back on the hands-on exercises. These are very important exercises. This will help you to improve your understanding around dashboards and this particular example. It will also help you when in a real world scenario, when you want to add more stores, you want to add more matrices, how you want to deal with this kind of a projects and the software 3.0. So make sure you try the exercises, and I would say please make sure that you do exercise on each and every lessons that we complete. Now let's go back on our presentation and find out what next left there. Here we are back in the presentation. Now the loop has a memory that you can read, controls if and justify, that gives the read feedback signal. Instead of building that reputation, next we will increase the pressure so the loop doesn't get too comfortable. And that's all for this lesson. Please make sure you subscribe and also press the notification bell icon. So next lesson we release, it straight away come to your timeline and your notification. And I'll see you in the next lesson. Take care then.